Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the channel. Make sure you like this video. Make sure you share this video. And also go ahead and drop some comments down below. All right. Now, today, we are going to be factoring by grouping. All right. Factoring by grouping. And why is it called factoring by grouping? It's called factoring by grouping because before we actually factor, we got to create groups out of the terms inside the expression. So right here, we got this expression which has 4 terms, and we're going to create 2 groups of equal size, right? So one group is going to have 2 terms in it. The other group's going to have 2 terms in it. And also something else you should know is that terms are separated by plus and minus signs. So it's not like 4 is a separate term and x cubed is a separate term, because terms aren't separated by multiplication or division signs. Terms are separated by plus signs and minus signs. That's one of the foundational and fundamental rules of algebra that you have to understand. All right. So 4x cubed is your first term. 2x squared is your second term. Negative 2x is your third term. Negative 1 is your fourth term. So my first group is going to be these 2 terms. Sometimes you got to like rearrange the terms. You have to, but sometimes you can do it just if you feel like doing it. You know what I'm saying? But it's not going to affect your final answer. You're going to end up with the same final answer, even if you like rearrange the terms. You know what I mean? But at any rate, let's make our groups first. That's what I like to do. So if we make our groups, I'm going to say the first 2 terms is one group, and then the second and third term, the third and fourth term is our second group. So basically, when you factor by grouping, you find the greatest common factor of each group. And you factor that way using the greatest common factor method. So what does that look like? That looks like this. Out of these 2 terms, I'm looking for the GCF, or the greatest common factor. So I look at my coefficients first. I got a 4 and I got a 2. I got a 4 and I got a 2. The greatest common factor of 4 and 2 is 2. So therefore, I know that 2 is part of my GCF, right? So I write a 2. Then I look at my variables. I got an x to the third and an x to the second. So they both have x in common, but which one do I put in the GCF? The rule is you put the x, or whatever the variable is, with the smaller exponents, or the smallest exponent. 2 is less than 3. So that means I'm going to use x squared, not x to the third. Smaller exponent. Remember that. Smaller exponent when we're dealing with the GCF. When you do problems dealing with the LCM, you take the variable with the bigger exponent. Right? When you see problems like that down the road. So my GCF is 2x squared. Then I write parentheses like this, because I'm going to have a binomial, right? That this GCF gets multiplied by, and this whole expression will be equivalent to what I started with, right? So now, how do I get what goes in here? They're quotients. Quotients of what, though? When I divide the original term by the GCF. Original term by the GCF, original term by the GCF. Those quotients go here and here. So what's 4x cubed divided by 2x squared? That's going to be 2x. Now, you watching this video, make sure you know why that's 2x. All right? When you sit in class, you watch your teacher up at the board doing problems, make sure you know why they are writing what they're writing. Okay? Why did I write 2x? Because what is 4 divided by 2? It's 2. That's why I wrote a 2. What's x cubed divided by x squared? It's x to the first power. That's why I wrote x. Why is it x to the first power, though? Exponent rules, division rule of exponents, division property of exponents. When you divide, you subtract the exponents. 3 minus 2. 3 minus 2 equals 1. Therefore, we have x to the first power. How come there's no exponent written? Because another rule you need to know. When the exponent is 1, you ain't got to write it. When the exponent is 1, you ain't got to write it, but you got to know that it's there. All right. Now, 2x squared divided by 2x squared is plus 1. How do I know that? Because whenever you divide something by the same exact thing, the quotient is always going to be 1. Even if you divide a billion by 1 billion, the answer is 1. -5 divided by -5, the answer is 1. It don't matter if we talk about numbers or variables. It don't even matter. It don't make no never mind. All right. Now, we go over here. Now, when you see a situation like this and you're looking for a GCF, the GCF of these 2 is 1. It's just 1. Because if you compare -2 and -1, the GCF is 1. This as an x term, this does not. So x is not even common. So in this situation, the GCF is 1. And that's fine. That's going to happen sometimes. All right. Now, here's the question, though. And I'm going to tell you just from experience. The question is, should you use the GCF of -1 or +1? -1 or +1? As a rule for me, if my third term, when I'm factoring by grouping, if my third term is negative, I use the negative GCF. That's just a rule. You don't have to do that, but it works out. It always works out for me, right? So instead of using +1 for my GCF and writing +1, I'm gonna use -1 for my GCF. And I would make a note of that if I was you. I'll write that down on my notebook, right? Well, my third term, first term, second term, third term, if my third term is negative, then I'm using the negative for my GCF instead of the positive version, right? So now I got -1. Then what goes in the parentheses? The quotient, when you divide -2x by -1, that's going to give you +2x, right? And then -1 divided by -1 is going to give you +1. Now, let's back up a little bit, because this is why, as a rule, me personally, I use the negative GCF and not the positive GCF. Because what would have happened, and this is something else you should do as you're doing math problems, you should always imagine and think about what would have happened if you took another route. Now, if you had used the positive GCF, you wouldn't have been wrong per se, but you wouldn't have got an identical binomial, because I already got 2x plus 1 as my binomial over here. When I factor by grouping, I want to have binomials that are the same. So I need another binomial, which is 2x plus 1, in order for this to work out at the end of the day. But if I'd have used +1, then what would have happened? I would have had -2x divided by +1, which would have been -2x. Then I would have had -1 divided by +1, which would have been -1. We would have had the same terms with different signs. So we still would have had to factor out a -1 in order to create identical binomials, because that's something else. Put that in your notes, matter of fact. You need identical binomials when you're factoring by grouping. Why do you need identical binomials? Because you need for the binomial to be your GCF in your next step. So right now, this is a binomial basically. I know it might not look like it, because 2x plus 1 looks like a binomial, right? 4x cubed plus 2x squared by itself looks like a binomial. This don't look like a binomial, but it is one. Why? Because what I tell you, terms are separated by plus and minus signs. This is a minus sign. And no, this plus sign don't count, because these expressions are inside parentheses. So that don't count, right? But this whole thing is a term. This whole thing is a term. 2x squared is a coefficient. -1 is a coefficient, right? What do these terms have in common? 2x plus 1. The 2x plus 1. 2x plus 1 is what they got in common. So that means 2x plus 1 is the GCF of both of those terms. 2x plus 1 is the GCF. So if 2x plus 1 is the GCF, what do you do with the GCF? You write it. You do 2x plus 1, put it in parentheses, and then put another set of parentheses next to it. And what goes inside the parentheses? The quotient, when you divide this whole term by 2x plus 1. What's the quotient going to be? It's going to be 2x squared. Once again, make sure you, watching this video, know where the 2x squared came from. 2x plus 1 divided by 2x plus 1 equals 1. Because whenever you divide something by the same exact thing, the quotient is always 1. Then you take the 2x squared, multiply that by that 1, you get 2x squared. Then you do the same thing over here. -1 times quantity 2x plus 1 divided by 2x plus 1 is just -1. Because the 2x plus 1 basically cancels out with the other 2x plus 1. Just like in this step when we divided this by the GCF. All right? So now we're done. This is the final answer right here. 2x plus 1 times 2x squared minus 1. And that's factoring by grouping. All right? So factoring by grouping, just make your two groups, right? And then basically you're just taking the GCF. Factoring by grouping is really just using the GCF method. That's all it is. Except when you got 4 terms, or you got 6 terms, or maybe even 8 terms or more, but an even number of terms, then you just create groups. And you basically take this larger expression, in this case with 4 terms, and you break it up into 2 smaller expressions, like 2 binomials. And you just use the GCF method, greatest common factor method, and just break it down. All right. So yeah, we out here. We out here using factoring by grouping. I got one of my Malcolm X t-shirts on, you know. So yeah. So make sure you know how to factor by grouping. All right. Make sure you know how to factor by grouping. When you first see the problems, take a moment, size the problem up, look at what you're working with, create your groups, and then find the greatest common factor of each of the groups, and then break them down like that. Boom, greatest common factor. Find out what goes inside the parentheses. Over here, boom, greatest common factor. Sometimes your greatest common factor is going to be a 1. Sometimes it's going to be a -1, and that's cool. That's all right. That don't mean you did nothing wrong. Sometimes that's just what it is, you know? But as long as your binomials are identical, your binomials got to match up. If your binomials don't match up, then you either did something wrong or maybe it can't be factored this way. And that's a possibility too. Everything is not factorable. We call that irreducible. If it's unfactorable, it's irreducible. All right. But in the event that your binomials are identical, that means that it can be factored. And then what you realize, what you're doing is you about to find the GCF again. Use the GCF method again. Except in this case, the GCF is not a single term like 2x squared or -1. It's a binomial. Well, I should say it's not a monomial, it's a binomial. Because 2x plus 1 is a term, right? But the term itself is a binomial. All right, so that's your GCF. And then you figure out what goes inside the parentheses next to it by doing division. Divide by that, divide by that. That's it. All right. Now, go get some more practice with factoring by grouping. Study Malcolm X. I'll see y'all on the next video. Peace.